question from the previous classes, please ask. What I told you, now we have a strong foundation, right? I am expecting you all have clear and crystal mindset about enterprise network, like which kind of devices are there, what is the purpose of that network, and how we are configuring LAN and WAN. Some more technologies are there. Now we are going to learn it in next 3 to 4 days. Is my screen visible, guys?
Yes, sir.
So this was our last class. So here I had given you this example that like on router number 2, if you need to configure policy to update the next hop IP address in the BGP, then how you will use ACL. What I had told you, ACL will be used in the policy, in the NAT, in the VPN, in QS, in security, route filtering, right? Everywhere you are using ACL. There are two purposes of ACL. One, to match the traffic for interesting traffic. Number 2, to allow or deny the communication, right? We had also seen when to use a standard ACL, when to use extended ACL. What is the difference between numbered ACL, named ACL? Where to apply a standard ACL, near to destination or near to source? Where to apply extended ACL, near to source or near to destination, right? Again, I am revising it once. See, ACL access control list is a list conditions that either permit or deny packets based on certain criteria, and these criteria are nothing but rules, right? Rules configured by network engineers on devices. These rules can be configured with the help of source IP, destination IP, protocol, and port numbered. Why we use ACL? Traffic filtering, to allow or deny user traffic. Second, number one reason. Second reason, for route filtering, to control which route are advertised or accepted in routing protocols like OSPF, EIGRP, BGP, etc. Number 3, in case of NAT, in case of QS, to define traffic that should be NATed or that should given priority. Number 4, in case of VPN, right, to again define interesting traffic, that which traffic should go through tunnel. And in case of policy, fifth one. After that, we had seen types of ACL. So standard ACL, extended ACL. Standard ACL filters traffic based on source IP address, can't check destination IP, can't check protocol, can't check port number, right? So you are blocking everything. If you will block the IP, that means all types of communication is blocked. All traffic is blocked. Doesn't matter if it is HTTP or TFTP or Telnet or TCP, UDP, ICMP, doesn't matter. If IP is blocked, because all these protocols works on IP only. IP is the core protocol, right? So can't check destination IP, can't check protocol, can't check port number. And this was the reason why you should apply a standard ACL near to destination, not near to source. Used mainly near to destination to avoid blocking too much traffic so that it cannot impact other traffic. After that, we had talked some more about a standard ACL. Here I had given you this example. I think you guys have remembered it. Right, this was my networking department. My requirement was only networking department, like network engineers, should be able to access these router through telnet or SSH. Then we have talked about extended ACL. Extended ACL filter traffic based on source IP, destination IP, protocol, and port number. Allow HTTP traffic from this subnet and block everything else. Here you have to use extended ACL. You can't use extended ACL because here we are matching what? Service, HTTP. That is not possible in standard ACL. Standard ACL doesn't check port number, right, which is your service. Then numbered ACL, named ACL and numbered ACL, right? So if your rules are identified by name, that is called named ACL. If your rules are identified by number, then it is called numbered ACL. And we had range, right, for both types of ACL. For standard ACL 1 to 90, for extended ACL 100 to 199. And we had some advanced range as well, but I had told you that now you don't need to learn that. Here, what was the issue in named numbered ACL? this ACL is not much flexible, right? You cannot modify the statement easily. You have to remove and then add the new statement. That's why we come up with named ACL. I had also told you numbered ACL is the old method of allowing or denying the communication, old method of controlling either control plane traffic or data plane traffic. The new modern way is named ACL, right? And this was the syntax to create named ACL, IP access list extender or extended after that name, and then you can define the action, then you can choose the protocol, then you can choose the source address, destination address, and equal to port number. I had also told you that ACL can be applied in two direction, either in direction and odd direction. If you want your ACL rules should be checked before routing decision, then you will apply ACL in inbound direction. And if you want ACL rules should check after routing table decision, then you will apply ACL in outbound direction. And I had also told you that whenever you are purchasing connectivity, WAN connectivity from the ISP, purchasing WAN connectivity is nothing but like buying the public IP address, right? You all are using mobile internet, right? So you are paying, recharging every month. Actually, you are paying for your public IP address. That's it. So when you are buying a public IP address from the ISP, from your RIR, they will only allow that IP address on their interface. Rest all the IP addresses are blocked, right? For an example, here you can see LAN subnet is 192.168.1.0/24. So user in this subnet will be using private IP address and they can't send any traffic to internet router because all the private IP addresses are blocked. Only this subnet, public subnet, is allowed on the internet router, and here we had stuck. Now if I will explain this in little more, if I will talk little more about this issue, then understand, or directly I can design the lab here. Let's suppose I have one router and this router is connected with one ISP. For an example, only one ISP. Later I can create more ISP as well, and we can learn NAT failover, right? Like between multiple ISP, how you will configure the NAT failover. And remember, in case of static routing, we had also talked about IP, SLA and track. Yes or no? So those features will be used in NAT also for NAT failover. Whenever you need to configure failover, you have to use SLA, right? Like we had used in static routing. Similarly, we will use it here in the NATing also. So let's suppose this is my ISP, or directly I can say internet. This is internet router, and behind the internet we have one server. Let's suppose public server. Here I can take one VPC. You can assume this is Google server on the internet, Google server, and I can change the symbol as well for to make it realistic. Just I am changing the symbol. I will use any server here. Let's suppose this is my Google server connected on internet, and this is my edge router of company, and beside this, behind this edge router, there is one switch, or you can have multiple switch. You already know the LAN network, right? Like there will be multiple distribution layer, multiple access layer switches, right? And they will be connected in 3-tier architecture in case of enterprise network. For data center, we have different architecture. We are using leaf and spine. I will also talk about that architecture, data center architecture, because see, in the enterprise, our traffic is east to west. Like LAN user is accessing internet right, or other side through internet. In the data center, your traffic is going to be north and south, right? Don't worry about that. We'll talk later. We'll see that architecture as well. For now, just focus here. This is my network, enterprise network. Here you can see the LAN users. This is my edge router, right? You can say customer edge router, and this is ISP router, public router. So on my edge router, if you will check, if you will see, there are two sections. My edge router is connecting two types of network. Which network we will run here, or which IP addresses I will configure here in this section? Private or public?
Public.
Here we will configure public IP address, right? So this is public network, and this is private
network.
network. And remember, by default, I'm saying what? By default, private and public can't communicate with each other. Why by default private and public can't communicate with each other?
Because private IP addresses are not allowed.
Yes, in case of IPv4 addressing also, we had seen that private IP addresses are not routable on the internet. Private IP addresses are not routable on the internet. First of all, ISP is going to apply one ACL here, which will be blocking your all private IP addresses. But even if ACL is not configured, then also ping will not work. Let's suppose this server is using IP address 203.1.1.1. This is the public IP address. Here my public subnet is, for an example, 1.1.1.0/24 or /30. Let me use /24 because we need to discuss all types of NATs here. So in dynamic you need to create pool. And here my private range 192.168.1.0/24. Right? So the IP addresses which I am using here is private, and the IP addresses which I am using over here is public, right? So this is public network, this is private network, and by default private and public cannot communicate. First, if I will talk about the routing, so how you will perform routing here? You will configure one default route on your edge router, right, towards ISP. What is default route?
IP route, yeah.
Default route is, you know, like the last before route or the default action, right? Default action. Let's suppose I have planned with my family today for dinner, right? Outside, for outside dinner, right? And we have decided even the food and those all things that what we will order. But let's suppose because of any reason that food is not available. So we have one default list of the dinner that if any time, if our food is not available in the restaurant, then we will go with this. Let's suppose with paneer and roti, chapati and plain. So that is our default choice. Okay, if I will not find any specific food, similarly if router will not find any specific route, then router will use default route to forward the traffic, right? Default route will be only used for those prefixes which are not present in local routing table. So default route is configured towards internet, but internet router is not going to configure any routing. You know what internet router will do? As soon as you are going to buy this public subnet, internet router is going to advertise that in BGP, right? Because this is one ISP, let's say ISP 1 Airtel, and this ISP need to advertise your public subnet to other ISP as well. Internet is what? Group of ISP. Networks of network is called internet. So as this is public subnet, it will advertise to public network, right? That will be the only routing inside the public network. Nothing else. They will not configure any route for this private IP address. Even ISP router don't know about the private IP addresses, what private IP addresses you are using inside your company network, and the private IP addresses are reusable, right? Like me, many people are using same IPv4 subnet. So now routing is done. Now let's suppose this user who is using IP address 192.168.1.1 will access, let's say, internet 8.8.8 or 203.1.1.1, source IP 192.168.1.1, destination IP 23.1.1.1. First of all, user will type www.google.com in the browser. DNS will resolve domain name into IP address, and they will get the public IP address. Like, for if you want DNS as well, you can add one more router here, right? This is your DNS server. DNS server, which will be resolving domain name into IP address. Okay, so at the end, PC will got the IP address, right, of the destination server, and they will generate the packet. In the packet, at layer 3, source IP and destination IP will be there. At layer 4, port number, right? At the application layer, actual data, the HTTPS request. At layer 2, source MAC, destination MAC. Destination MAC will be what? MAC address of gateway. Means this PC is going to forward traffic in different subnet, so it will forward to their gateway at layer 2. So traffic will reach to R1. R1 will compare destination IP with routing table, and like this IP address, guys, million of servers are there on the internet, right? It is not possible to install the routes, individual routes for public IP addresses. So that's why default route is there. Destination will match in default route, and then router will forward traffic to internet. So internet router is going to again compare destination IP address with routing table, and destination IP is public IP address, so it can route the traffic. It will forward traffic to server. But when server will generate reply, then source will be 231.1.1.1, and destination will be 192.168.1.1. And now this server, Google server, will forward traffic to internet, and this time internet is going to compare this destination IP address with their routing table, and destination IP is private IP address, so it will drop the packet. It will drop the packet because route will be not there for private IP address. That's why your packet will get dropped. Clear, everyone? So what we will do here, we will configure NAT. Now, what is NAT? NAT is a technology. First, remember, by default, private and public cannot communicate with each other. And NAT is a technology, or you can say NAT is a process which is used to make it possible, which is used to make communication possible between private and public, or public to private. Got it, guys? What is NAT? Technology used to make communication between private and public subnet. How? With the help of translation. What will happen when user will generate traffic? Traffic will hit to my gateway, and my gateway device will be performing translation. See, destination IP 23.1.1.1. It will perform source NAT. Source NAT means the source address will be translated. Source address will be translated. So source IP is the only private IP address. Router 1 is going to change the source from 192.168.1.1 to any public IP address. You can use any public. Let's suppose 1.1.56. I have used this public IP address for netting. So router 1 has translated the source. Now traffic will reach to internet router. Internet will forward to server. This time server will generate reply for this public IP address, and internet router can route the traffic. But when reply will come back, how router will understand to whom I need to forward? Because now again router need to translate public into private. So router is going to maintain a table called translation table. Router will maintain a table called translation table. Private IP was 192.168.1.1. So it is going to translate this private into a public IP address 1.1.1.50, let's say. 192.168.1.1 destination 23.1.1, and router is going to translate the source, and it will maintain a table called translation table. In the translation table, it will maintain entry like this, that I have translated this private IP address 192.168.1.1 into 1.1.1. Let's say 50, right? This is translation table of NAT. Translation table, right? And here source is now 1.1.1.1. Sorry, not 1, it is 1.1.1.20. So it has, let's suppose, translated into 1.20, and then it will forward traffic to internet. Internet will route to server. Server is going to generate reply. In the reply, source IP address will be the public IP address 203.1.1.1, and destination IP will be what? The public IP address 1.1.20. This server will forward traffic to their gateway to internet. Internet router will check destination IP address, and it will compare destination with routing table. This time destination IP address is public IP address, right? So there will be route for this public IP address that this network is connected on F0/0. ISP router will forward from here, and router is going to check again the packet, that is the reply matching in my translation table? Yes, destination IP address is 1.1.20, and I have translated this private IP address into this public IP address. Means now I need to revert back, right? Now I need to translate this public IP address into the private IP address 192.168.1, and then it will forward to the PC. This way it is going to work. Similarly, let's suppose now 10.2 has also generated the traffic. 10.2 has also generated the traffic. (192.168.1.2), and destination IP address is same 203.1.1.1. Again this traffic will reach to my router. Router is going to change the source IP address, and it will maintain NAT table. It is going to store like 192.168.1.1, and let's suppose I have translated this IP address into 1.1.21, right? So here source will become public 1.1.21. It will forward traffic to internet router. Internet will forward to server. Server will generate reply. In the reply, source IP will be public. Destination IP will be also public 1.1.21. It will send to internet. Internet will send back to router 1. Router 1 is going to compare with their NAT table, and in the NAT table here you can see the public IP address. Again it will revert this public IP address into the private IP address 192. This one is 2, not 1, 2. 1.2. So it will again translate public IP address 1.1.1.21 into 192.168.1.2, and then it will send to PC. But in this way you can see, if I have 2 users, I need how many public IP addresses? 2 public IP address, right? If I have 100 number of users, I need 100 number of public IP addresses. Guys, public IP addresses are not free, it's payable, right? We can't purchase lots of public IP addresses like 1 for 1 user. No. So NAT translation is not going to be like this. There will be some more extra information, but this is the foundation, that when private user generate traffic for the internet, router will translate the source. When reply will come, router will translate the destination, right? In the request, your source is private, so source private will be translated into the public, and when reply will come, so reply will come on that public IP address. Again router will change the destination, which is public, into the private IP address, and then forward to LAN users. Similarly, here let's suppose I have one server. Now this is my server. PC2 is server 192.168.1.2, and what I want, all internet users should be able to access this server, right? So let's suppose here I have configure 1-to-1 mapping. 1-to-1 mapping is like a static NAT, which is bidirectional, right? See, unidirectional means you can access internet, but internet cannot access you. right? Means all the traffic from inside to outside will get translated. The source will get translated. That is unidirectional NAT. If I will talk about the bidirectional means the one private IP address will be mapped with one public IP address, right? Let's suppose here manually I have mapped one private IP which is 192.168.1.2 into 1.1.50. So if someone is going to hit on this public IP address, router will automatically translate it into this private IP address. Or if someone is going to hit on this private IP address, router will automatically translate it into this public IP address. That is one-to-one mapping. So now if this router, let's suppose this is user now on the internet whose IP address is public 203.1.1, and this user want to access my private server, they will send request on this public IP address. This public IP address, see like this, source IP 203.1.1 and destination IP 1.1.50. Request will reach to this router. Router will check, compare this with NAT rule, and based on that it will get to know that okay, this public IP address need to translate into this private IP address. So router is going to change this IP address into 192.168.1.2, and then it will compare with routing table. If someone will ask you, router will check first NAT table or routing table, what will be your answer? Which table will be checked first? And interviewers are asking these kinds of questions multiple times.
NAT.
NAT table, yes, then routing table. Now router will compare destination with routing table and it will forward traffic to PC. So this way anyone from the internet can access my PC. This is basic logic behind NAT. Now let's understand the theory, then I will show you the configuration. So what I told you, what is NAT? Tell me the definition. Type one line definition in the chat. Type one line definition in the chat. Let me see how many of you are able to answer. In the interview as well, your answer should be always short and very clear, right? Like if interview is asking what is NAT, so you only need to tell what is NAT. No need to explain anything else like NAT, how NAT works, types of NAT, nothing. Only NAT. Like NAT is a technology used to make communication between private and public with the help of translation. So it is responsible to translate private IP address into single public IP address. No, this is incorrect definition. NAT is the process of translating private IP address into public IP address for the use of internet. Again, not the right answer. Networks. Types of NAT. Static NAT. Second one is dynamic NAT, which is not in use nowadays. Not in use. You will understand why. And number 3 is PAT. PAT stands for port address translation. You guys must have heard about port forwarding or the virtual IP. Yes or no?
Yes.
Whoever are working must have heard about the virtual IP, port forwarding. Even I have configured port forwarding on my edge router. Let's understand these three types of NATs one by one. Tell me first, what is a static NAT?
So that's a situation where you have one private IP address mapped to one public IP address.
A static NAT, it is 1-to-1 mapping, means one private IP address will be translated into one public IP address and vice versa. And vice versa. This is it is bi-directional. What is the meaning of bi-directional? Bi-directional means
Both checkpoints.
yes, it will work in
Forward.
both the direction, means you can also access internet, internet can also access you. What is the use of a static NAT? Used to access private or internal private server from internet. Whenever you have a private server and you want outside user, internet user should be able to access that server, you will configure what? A static NAT, right? Like I have hosted SD-WAN lab on my server, and which is located in my private network, and I want user from the internet should be able to access. So I have a static public IP address I have purchased from the ISP, and if you also want to get the real time knowledge that how to purchase IP address, public IP from the ISP, you can call to your ISP, right? Only for learning, right? You don't need to buy. You can inquiry about the public. Hey, I am looking for a static public IP address. What will be the cost? How it will work? Who will be configured? How it will be configured? Like that. Similarly, if you want to like learn the MPLS, how service providers are selling MPLS service, you can call again to your service provider and ask for MPLS connection. You can like say I have two location at one at this side, location one at this side, and I need one point to point connection. So you can get real time information about these services, like how service providers are selling. The internet which we are purchasing is the dynamic public IP address. That is not a static public IP address. But for a static NAT, we need a static public IP address. Right? So a static NAT will be used when my router is connected with internet, R1, connected with internet, and I want internet users to access my internal server. This is internet. In short, I can say INET, and here are users, internet users with any public IP address 2.2.2.1, 2.2. or 21.1, like any IP addresses. These are the users on internet, and inside your company network you have one server whose IP address is, let's suppose, 10.1.1.1, right? And here on the WAN link you have one public subnet 1.1.0, 0/24. So from this subnet, you can use any one public IP address for this particular private server, right? Let's suppose my public IP address of this server is 1.1.50, right? So you will share this public IP address with internet users. Like, hey, you can access my service, the application which is hosted over here, app1, through this public IP address. So I have also hide my private IP address. Now my private IP address is hidden for outside user. Outside user will never get to know about my private IP address, that what private IP address you are using. They only know the public IP address. Or you can share the domain name with user and your ISP can configure the DNS. Right, like resolve this IP address with this domain name. Let's say pmnet.com. pmnet.com IP address is 1.1.50. So if anyone from the internet is going to browse this IP address, DNS will resolve into this IP address and then they will hit on this public IP address. My router will perform one-to-one mapping. In one-to-one mapping, this private IP public IP address will be translated into 10.1.1, which is my private IP. Public IP address will be translated into my public IP address. This is one-to-one NATing. Let me show you one-to-one NATing. For an example, 192.168.1.1 is my server, right? Or let's suppose this one is my server, this router. Which server? DNS server. And I want these internet users should be able to access this DNS server. And after that, this can be your DNS server, DHCP server, this can be HTTP server, FTP server. To make it easy, let me say this is web server for now. And now, soon I will change the server. Okay, you can imagine this is web server and here my IP address is 192.168.1.10. Done. Let me configure the IP. DNS server or web server, R1, internet router and public server. This public server is nothing but the user on internet. On the internet, I can configure DHCP so that internet users can get IP address automatically. Similarly, your service provider give you the DNS service, DHCP service, right? By default, these services are integrated with public IP address. If you will purchase the internet connection, it will give you the DHCP service as well. So interface F1/0, no shutdown. IP address, let's suppose here I have configured IP 23.1.1.100, the public IP 255.255.255.0, and I am going to enable DHCP IP, DHCP pool, let's suppose Cisco, pool Cisco and network 23.1.1.0, mask 255.255.255.0, and default router default router is going to 3.1.1.100. That's it. Now this user can get IP address, IP DHCP, DORA process will work. Now see, got the IP address, public IP address 203.1.1.1, and this is the gateway. I can ping even gateway 23.1.1.100. Right, gateway is reachable. Very good. Now go to internet and configure the customer facing WAN interface, means interface F0/0, no shutdown. IP address, or here I can also add the description that this interface is connected to PM networking LAN network or edge router, like this, right? And then IP address 1.1.2.255.255.255.0. Here I have configured .2. You can configure any IP address, doesn't matter. Let me save the configuration and let me take you to the internal router. On the internet, I can also create one loopback 8.8.8 for testing. Interface loopback 1, IP address 8.8.8.8. This is again another user. You can imagine, like on the internet, one more user is there, which is 8.8.8. which is 8.8.8. Now go to R1 and configure your edge router. This is the service provider configuration. You will not configure this router. Your configuration will start from here, from R1. Now I am going to close the console of internet router because I will not configure anything. Even you are not allowed to configure or access internet router. So let me close the console. Let me save the configuration. Let me verify the IP configuration once. So IP interface brief. You can see IP configuration is correct. Right now I am going to close it. On the internet router, I have only configured the IP addresses, nothing else. Go to R1, configure WAN interface first. Description, connected to ISP, IP address 1.1.1, let's say 255.255.255.0, and no. Shutdown, exit. You can add one more command here for the NAT, that this interface is outside. See, in the NAT we have some zone. First of all, for now you can understand two zone, inside zone and outside zone. And now you will understand inside global and outside global as well. Inside means internal network or private network. Internal or private network or interface. Network, say let me say network. And outside means
External.
public or WAN network. So here in my case, this interface is going to be my inside and this interface is going to be my outside, right? And then you have some two more zone, inside, local. Okay, I will talk, just wait. First of all, let me configure this interface as IP NAT outside. I said this interface is outside. And now let me configure the LAN interface, F0/0, IP address 192.168.1. Let's suppose 100.255.255.255.0. This will be the gateway for LAN users, and IP NAT inside, exit. All good? Do so IP interface brief, exclude unassigned. Now see, I have configured the IP addresses. Now who will tell me one thing, that can I ping 8.8.8 from R1? Can I ping 8.8.8 from R1?
No, sir. No.
Why?
Translation is not enabled. There is no pool. There is no public pool.
No translation is required to ping 8.8.8, right? Router 1 is using public IP address. It can forward the traffic to 8.8.8. There will be no any translation when I will ping internet from my edge router. Translation is required when you will ping internet from the LAN side, right? Not from the WAN side. Routing is not there, right? Answer is routing is not there, Praphul. If you will ping 8.8.8, router will simply compare destination IP with routing table. So IP route 8.8.8. If a specific route is not there, then it will check default route, and default route is also not configured. So router 1 will drop the traffic. So let me add one default route here. IP route 0.0.0, 0.0.0, exit interface F1/0, and next hop IP 2.2.2. Now can I ping 8.8.8? Yes, you can ping 8.8.8, Praphul. Why ping is not working?
Next hop is wrong.
Next hop IP address is
1.1.2.
1.1.2.
So say no to this, and next hop is 1.1.2. Okay, now ping 8.8.8. You can see ping is now working. But can I ping 8.8.8 from the LAN interface, source F0/0? No, this time ping will not work, right? Even you can check request is going to ISP. You can access internet router once for testing. You can debug IP ICMP to check, debug IP ICMP, and then ping to 8.8.8 from your LAN interface. You can see on the internet traffic. Internet router is generating the reply, but destination IP address is what? Private, right? And there is no route. So IP route 192.168.1.100, there is no route available to forward traffic to this IP address. That's why internet router is dropping the traffic, and this is the reason why you are not able to ping internet from the LAN interface. Got it? Now here translation is required. Translation is required. Right now I am talking about one-to-one translation, a static translation. Means I don't want LAN users, my LAN users should have internet access. I want one-to-one mapping, means anyone from the internet can access my server, this server. So you are not going to use any ACL, you are not going to configure like dynamic NAT or PAT. Simply you need to configure one-to-one mapping. For that there is one command, IP NAT inside. Inside means what will be the inside IP address, means source. Inside can be matched from the ACL, or you can define manually. See inside, and after that source or destination. So source, inside source. What will be the source? Source can be matched through list. List is ACL list, means if I will say 10, so it is going to match source IP address from access list number 10. Whatever source will match from this ACL will be translated. Source can be matched through route map also, or source can be identified, mentioned statically also. So for one-to-one NATing, we will configure source statically. What is the source IP address? And now it is asking for inside local IP address. Inside local is my private network. My private network. So inside local IP address is 192.168.1.10. 1.10. Then what is inside global IP address? Inside global means your public subnet. Your public subnet. See, if I will talk about the Google network, guys. So Google network, Google has also what? Private network only. Google has somewhere their data center, and in their data center lots of servers are there. Yes or no? Those servers are also using private IP address. That is the private network of Google. Google. Okay, and now this Google is connected with, or you can imagine Google or any cloud provider like AWS, Azure. Everyone will have similar kind of infrastructure, right? That is their local area network, their data center network, where multiple servers are connected. Forget about the architecture. Doesn't matter it is leaf spine architecture or 3-tier architecture or 2-tier architecture. I am talking about LAN and WAN. That's it, nothing else, right? So here Google private network is connected with internet, iNet. Maybe Google is using public IP address directly here, 100.1.1.0/24, or maybe they are using private IP address in the LAN and then configure a static NAT to access this server through public IP address. There will be many more devices like load balancer in the Google data centers, so that we can distribute traffic over multiple servers. But I want you to understand the logic, right? So let's suppose Google is using private IP address for now, 192.168.5. or 50.0/24, and the public IP address of, or public subnet of Google is, let's suppose 100.1.1.0/24. So for Google this is inside local. For whom? For Google, but not for you. Now here is your private network. Again your router, edge router, connected to internet. Behind the edge router you have switch, and this switch is further connected with again lots of PCs, employees. This is your private network. My private network, and my private network is also connected with internet. Let's suppose my private subnet is 10.1.1.0/24. My public IP address is 1.1.0/24, my public subnet, right? This is my company network. Let's suppose PMNet, PM networking subnet, network, private, public. So for me, understand this very carefully. This is inside local. Inside local means my private network. This is inside global means my public subnet. What is this? My public subnet. My private subnet is called inside local. My public subnet is called inside global. And for you, for PMNet, Google network is outside either local or global. So this can be either, this will be your outside local means the private subnet or private network of Google, and the public network of Google will be your outside global. These are the zones, right? Zone is nothing but the region. So this way you will configure the NAT. If you are configuring on router number 1, let's suppose inside local IP address means it is talking about your private IP address. If it is asking for inside global IP address means it is asking for your public subnet. If you are configuring outside local IP address, that means public subnet of Google network, or outside local means private subnet of Google, right? So here in the configuration you can see now it is asking me for what? Inside global IP address. First it has asked me for static. First it has asked me for inside local IP address. So my inside local IP address is means my private server IP address 1.10. Then question mark. Inside global IP address is 1.1. Let's suppose 10. 1.1.10, which is my public IP address for this particular server. Now you can say this server has one private IP address and one public IP address, which is 1.1.10. And now if you will put question mark, you can see just leave these all options for now, like route map and forced. Just my NAT is done. So IP NAT translation. You can see in the NAT translation table entry is permanent, right? This entry is permanent, and for static NAT you have not configured outside local, you have not configured outside global. You have only configured what? Your private IP address means which should be accessible through public IP address, right? Through like outside user means internet user should be able to access their private IP address. That is your inside local, your private IP, and inside global is your public IP address. Now if anyone from the internet, let's suppose this user server is going to ping the public IP address 1.1.10, what will happen? Traffic will hit to router, my edge router. Yes or no? It is public IP, it will be routable on the internet, and my router is going to translate the public IP address into private IP address. Like if I will ping from the, let's say, Google server, from this server ping 1.1.1.20. So you will ping to the private server, not the IP address which is running on router or internet, not at all. You are actually pinging to your internal DNS server IP address. How to verify it? Let's configure the DNS server as well. Go to config T. First of all, disable the routing. Say no IP routing, and interface F0/0, no shutdown, and IP address. IP address is going to be 192.168.1.10. 255.255.255 dot 0 IP default gateway. What will be the default? What was the default gateway? What default gateway I have configured? Are you guys here?
Yes.
Yes, sir.
It's 100. 1.100. Now I can ping 192.168.1.100 my gateway. Very good. But I cannot access internet. I cannot access internet. Go to Google server and ping this IP address, and here on the DNS server I am enabling debugging. Debug IP ICMP. Google server and ping this IP address. See. Timeout. Timeout. Why this ping is not working? I ping to 20. It should be 10. IP NAT translation. Yes, it should be public IP. Global IP address is 10. So let me ping 10 now. 10 here. And you can see ping is working, and you can see Google server is generating reply. Google server is replying to whom? To this destination, to the IP address of internet user.
Swapish.
Getting my
You
point?
have 192.168.120. Can you try 10, please?
Huh?
Because this
IP
DNS
ping
IP
10.
address is 10. 192.168. This is 10. You have ping on 20.
I have pinged to the public IP address 1.1.10.
No. Yeah, before line, you ping to the private IP address
No, before I ping
192.168.1.20. Yeah, 20 is 20. No,
1.1.20.
Yeah.
How internet user can ping private IP address? That is not possible, right? Internet user will ping to public IP address. Public IP address. Done, guys. What is happening? A router is not going to maintain a table. This table is static, you can see, right? It is permanent. This entry will be permanent. And here is your translation. You can see what is happening. What is happening? Someone from the internet is generating traffic with source IP address, this one, and destination IP address 1.1.1.10. That is inside local, and your router is translating, sorry, that is inside global, and your router is translating inside global into inside local, and you have defined what will be the inside local, what will be the inside global, and outside local and outside global is same. Here you can see this is outside local, outside global. If you have this kind of scenario, then this will be outside local and this will be outside global. For now, outside local and outside global is this server public IP address, and here is my inside local, here is my inside global, right? This is one-to-one NATing. Whenever you have requirement of having private server access from the internet, you will configure static NAT. But remember, for a static NAT, you need one public IP address for one private IP address. This is one-to-one mapping. Got it? If DNS server is going to on all, and from here also I can stop connectivity. Okay.
Sir,
Yeah.
ports are same in the public and private network.
Where is the port?
Translation, yes.
Forget about this port number for now.
This is dynamically created.
Yes, this is dynamically assigned, not created. Now, question is, can these users access internet? No, Praphul. Right? Still no, because we didn't configure NATing or any translation for these private users. So now let's understand dynamic NAT first. After that, I will talk about the actual NAT which we are using. Now dynamic NAT. Dynamic NAT. What is dynamic NAT? Dynamic NAT is many to many translation, means many private IP addresses can be translated into many public IP addresses. How dynamic NAT will work? Let me tell you that. Let's suppose again this is my edge router and this edge router is connected with internet. This time my requirement is LAN users should be able to access internet. Right? On the internet, some public servers are there like 8.8.8 or 200.1.1.1, right? Or subnet 100.1.1.0/24, like this kind of subnets or users are connected on the internet. Internet is connected with my router, internal router. This is my WAN interface F0/1, and here my public subnet is 1.1.0/24, right? Or let's suppose /27. So if I'm using /27, then how many valid IP addresses are there? Tell me.
30.
Tell me how many? 30? Really? /27 means how many host bits are there, guys?
5.
Yes. 30
5
valid
host
IP
bits.
addresses.
A usable 30 IP.
Yes. Total 32. Out of that, 30 are usable. Now, out of these 30 IP addresses, you can use some public IP address for translation, right? With the help of public IP addresses, group of public IP addresses, you will create a pool. That is pool of public IP address. Here my private subnet is 10.1.1.0/24 or 10.0.0.0/8. Lots of users are there in this subnet. Yes or no?
Yes. Yes.
1 minute. Lots of users are there in this subnet, and for the translation, let's suppose I have created one pool of IP address, IP pool, and in the pool I have some IP addresses from this range, let's say 1.1.20 to 1.1.23, right? I have a pool of public IP address. For dynamic NAT, you will always create a pool of dynamic IP addresses. How many IP addresses are there in the pool? How many IP addresses are there in the pool?
Wow.
4.
5.
4.
4.
4.
Yes, sir and madam. How many public IP addresses are there in the pool?
4.
4.
For 20, 21, 22 and 23. Let's suppose 22. Now how many? 3. 3 public IP addresses are there. Now, I said this is inside interface and this one is outside interface. I have configured the NAT and this is my pool of public IP addresses, and here are the private users using IP address 10.1.1.1. Let's suppose this user is using .2, this user is using .3, this user is using .4, right? When first user will ping 8.8.8, source IP 10.1.1, destination IP 8.8.8.8. It will forward traffic to router 1 to the gateway. Router 1 is going to match the source address. So if source address will match in the NAT translation, right, NAT rule, then it will perform translation, and for the translation it is going to change the source address, right. It will use any one IP address from the public pool. Let's suppose it has used, this is first request, PC1, right, and for PC1 it has used one public IP address which is 10.1.1.1 equals 1.1.1.20, right. Let's suppose this public IP address is used for this private user, right. Okay, great. This user is accessing internet, right, downloading something by using this public IP address. At the same time, let's suppose now another user PC2 is also generated request for internet. Their source IP address was 10.1.1.2. Now it is going to use another public IP address from the pool. Let's suppose 1.1.1.21,
1,
right, for PC2.
2,
Now for PC3 is also accessing. Now if PC1 will stop accessing internet, then this public IP address will get free, 1.1.20. Then that can be again used for another user. But let's suppose PC1 is working on the internet, has a still internet access. PC2 is also working, right. At the same time PC3 has also generated traffic for the internet, and router has used this public IP address for PC3. Done. Now when new user will generate any request for internet, let's say 10.1.1.4, it is going to look up IP pool for the translation, and this time you can see not any public IP address in the pool is free. If PC1 will close the internet session, or any PC will close the internet session, then only this user can access
Internet.
Otherwise can't access internet. Why? You will get what a error message here on the router. If you will just check the logs, you will see that it is giving you the log that all the public IP address in the pools are occupied. So disadvantage of dynamic NAT is what? If we have 3 public IP addresses in the pool, that means only 3 users can access internet at a time. At a time only 3 users can access internet. If you have 10 numbers of IP address, 10 users can access internet. But here you can see we have 2 power 24 LAN users. 2 power 24 minus 2 LAN users are there. Huge number of IP addresses, public IP addresses are required if I want all users should be able to access internet at a time. Here dynamic NAT failed. Here dynamic NAT failed. In the dynamic NAT, if you have 4 IP addresses in the pool, that means only 4 users can access internet. Let me configure it dynamic NAT once, so that my LAN users can access internet. In the dynamic NAT, I am going to create one pool, IP NAT pool, and name of my pool is, let's suppose, NAT pool, right? And then a start IP address. A start IP address is, let's say, 1.1.15, and then end IP address is 1.1.1.16. How many IP addresses are there? 2. 2 IP addresses are there in the pool. Then net mask 255.255.255.0. Here you have to define prefix length or net mask 255.255.255.0. Right, and now I need to configure NAT, IP NAT inside source. This time I am going to match source from access list number, because this time source is not one IP address, so I can configure statically. This time we have 254 IP addresses in the source, so I am going to use access list number 10. And destination, now it is asking what? Destination pool. Your pool name is NAT pool. NAT pool means it will translate the private IP address into the public IP address which are assigned to this pool. NAT pool. Right, that's it. Enter. And now show IP NAT translation. You can see your translation table. Go to PC1 and let me try to ping internet. IP DHCP. Is DHCP enabled for LAN? If it is not
No,
enabled,
sir.
then let me configure
No.
manually. 1.1/24 and 192.168.1.100. Very good. Now here I am going to ping 8.8.8.8. If I am pinging 8.8.8, what will be the inside local IP address, guys? What will be the inside local?
192.168.1.1.
What will be inside global?
15. 1.1.1.15.
Any IP address from the pool? What will be
Yes.
outside local? Eight dot eight dot eight. Outside local and outside global both are 8.8.8. Let me ping and let me see ping is working or not. See, ping is not working. And so IP NAT translation, even in the translation you can see there is no any translation. Why? Because it is matching source from access number 10, from ACL number 10, and we don't have any ACL here. So in the ACL I am going to match, like through ACL. See, here I am using ACL to match my traffic, that what traffic should be translated. So access list number 10 permit 192.168.1.0 and wildcard mask 0.0.255. Any IP address from this range should be translated. Now go to your PC1 again and ping 8.8.8 again, and this time ping should work. You can see ping is working. And on the router, if you will check NAT translation, so IP NAT translation, so here you can see the translation. Inside local IP address was 192.168.1.1. Inside global IP address was 1.1.1.1, means translated address. Outside local and outside global was 8.8.8, and ping is working. Now I am keep pinging 8.8.8 from PC1. Let me access PC2 also. From PC2 I am going to say IP 192.168.1.2/24 and 192.168.1.100. Here also I am going to ping 8.8.8.8 hyphen T. This will be also pinging to internet. Now go to router 1, check the translation table. In the translation you can see 192.168.1.1 is translated into this public IP address, and 1.2 got translated into 1.16. Right? Now both the IP addresses are occupied in the NAT. If I am going to ping internet from this DNS server 8.8.8, ping working? How ping working? This is working through a static NAT, right? I have told you a static NAT is bidirectional. If any new user will try to ping internet, let me take you to router 1, and here I am going to say ping 8.8.8.8 and source F0/0. See, ping is not working. Why ping is not working? And here it is giving you the error message as well.
Because we have two IP address in port.
Address allocation failure. Address
And he had that
allocation
him
failed
at the
for
exhausted.
192.168.1.100 because pool NAT pool might be exhausted. Got it?
Yes.
This is dynamic NAT, and this is the reason why we are not using it. Nowadays you will not find dynamic NAT. When we had a static NAT and dynamic NAT, only that time we were using it. But then we come up with PAT, port address translation, and nowadays for internet access, like your general employees should be able to access internet. For that you will configure what? PAT, port address translation. And PAT is, what is PAT? Let me tell you. PAT PAT stands for port address translation. This is good thing is in dynamic NAT you need multiple public IP addresses, correct? You need multiple public IP address. Dynamic NAT is many to many translation, many private IP, many public IP address. But your PAT is many to one translation, many to one translation. What it means many private IP addresses can be translated into single public IP address. Many private IP addresses can be translated into
Single public.
single public IP address. How, Praphul, how it is possible? How router will recognize the reply packet? So understand how it will work. Let's suppose this is again my edge router R1. This edge router is connected with internet. PAT is also called as overload. PAT is also known as overload. In the configuration you will see the overload only. This is again my internet. INET. Behind the internet multiple public IP addresses are there like 8.8.8. It is connected like this. Here on my WAN port my public IP address is 1.1.1.1 and here is my LAN switch. And here are the LAN users. My private subnet, let's suppose 10.1.1.0/24. So all the private IP addresses from this subnet 10.1.1.1 will be translated into single IP address which is running on WAN port, which is running on my WAN port, let's say, which is running on F0/1. Okay, let's suppose this user is using IP address 10.1.1. This user is using IP address .2. This user is using IP address .3. This user is using IP address .3. What will happen when 10.1 will generate traffic for internet? Source IP 10.1.1, destination IP 8.8.8. It will forward the traffic to router and router will translate this private IP address into public IP address which is running on my WAN port 1.1.1 and destination IP is same 8.8.8. It will not change anything in destination IP. PC1. One internet user will generate reply. Destination IP will be what? 1.1.1.1, right? And again router need to translate destination which is public into source. But how it will recognize that? Let's suppose this user PC2 has also generated the traffic. Source IP 10.1.1.2 and destination IP 8.8.8.8, right? PC2 has also sent the traffic to your gateway to R1. R1 has translated source which is private into the public IP address, the same public IP address 1.1.1 and destination 8.8.8. This is PC2. These are the request message, right? PC2. One reply will come for PC1 as well as PC2. In the both reply, source IP will be 8.8.8 and destination IP will be 1.1.1. Here also 8.8.8 and destination 1.1.1, right? Let's suppose this PC has open Facebook. and this PC has open Instagram. Now how router will recognize that this reply message is for PC1, means now here I need to translate this public IP address into 10.1.1.1 and this public IP address into 10.1.1.2. This is the issue, yes or no? In both
Yes.
reply message destination IP address is same. So here what will happen, router is going to use your router is going to use port numbers for translation, right? What is the range of port number? What is the range of port number? Port number is 16 bits decimal value 02655535. We have
2 to the power 6.
this range, right? And out of this range, some port numbers are well known. Some port numbers are already assigned to the protocols. So router is not going to use well known port number. Router will use random port number, the free range only. Again issue, Praphul, that means okay, this is absolutely fine that many private IP addresses can be translated into single public IP address. But again, up to 65535, not 65535, 65535 minus well-known port number. Only that number of user can access internet at this time in the PAT also. There is limitation. So sir, you can use 2 IP address then, right? In PAT you can create what? Pool, right? Let's suppose here I have created the pool, and in my pool I have 2 public IP address for PAT, 1.1.1.1 and 1.1.1.2, right? So you can simply multiply the port number, available port number for translation by 2. If you need more, then you can use 3 public IP address in the pool for PAT. How PAT will work? Understand now? What will happen when PC1 is going to generate traffic for internet, which is accessing 8.8.8 source IP, 10.1 destination IP, 8.8.8.8. PC will send request to router. Router is going to compare source IP address in the translation rule, right? Source will match in the ACL number, right, which is defined in source. It will perform translation, and in the translation it is going to, it will maintain translation table. In the translation table it will maintain that source IP 10.1.1.1 is translated into 1.1.1.1, and now it will assign port number. Which port number? Free port number. Let's suppose here it has used P1 for source port and P2 for destination port. Similarly, PC2 has also generated request message with source IP 10.1.1.2. So your router is going to translate into 1.1.1, and it has assigned one unique port number. Let's say P3 and destination P4. Now, when internet will generate reply, source IP address will be 8.8.8, port number will be P2, and destination IP will be 1.1.1, and port number will be what? P1 for PC1 for first request. For second request, destination IP 8.8.8, source port P4, destination IP 1.1.1, and destination port number
3.
P3, right? Now when router will receive this request, it will understand that okay, 1.1.1 is the destination IP address and port number is P1. That means P1, port number P1 will be translated into 10.1.1.1 private IP address. So now router 1 can forward this reply message to PC1, and this reply message to PC2, with the help of port number.
Number.
Through port number, it can identify, right, that which public IP address or which reply message to forward whom. Got it? This is what? This is PAT, and nowadays we are using PAT only on the router, right? So you don't need lots of public IP address. Even single public IP address is sufficient in a small to medium size organization. In large organization, maybe you will have pool of public IP address. Let's suppose one public IP address can translate 65,000 translation. One public IP address can perform 65,000 translation. So two public IP address will perform translation multiply by 2, right? So we can multiply by 2. If we have 3 public IP address, we can multiply by 3, means this number of user can access internet at the time. So here now on daughter number 1, I am going to remove the dynamic NAT configuration and I am going to configure PAT. I am not able to remove because it is in use. So you can do one thing, clear IP NAT translation star, and then you can remove it. Do clear. I think users are still pinging. Yes, stop it. Stop it. And now go to router, clear IP NAT translation star, and no. I have removed it. Now I am going to configure PAT. First of all, again ACL is required to match source address, right? ACL will tell which IP address need to translate, right? For that we already have ACL. So IP access list, I already have access list which is matching the all source IP addresses. For NAT configuration, IP NAT inside source, right? For inside source, match source from access list number 10 and translate it into the IP address which is running on interface fast Ethernet 1/0. And for PAT you will use keyword overload. That's it. This is the actual implementation of PAT, and you will use PAT only for internet access so that your employees can access internet. And through ACL you know how to limit the internet access, right? Like users should only have the let's say HTTPS access, not able to ping, like that. So let me enter, and now if I am going to ping again from PC1 to internet, ping 8.8.8, you can see ping is working. Go to router 1 and check NAT translation, IP NAT translation, and you can see 192.168.1 means inside local is translated into this public IP address. And here is the port number. It has used this port as a source port number. This is first random port number, right? 021023 are well known port number, and it has used one random port number for destination. Randomly any port number. When PC2 will access internet, PC2, again PC2 IP address will also get translated into same public IP address. See IP NAT translation 192.168.1.2 inside local got translated into same public IP address, but use the different port number, and through port number it can identify the reply message to whom I need to forward which reply. And this way now 65535 minus 1023 users can access internet at a time, right? But let's suppose if you have more than 65535 users and they all need internet at a same time, because they all are working on, let's suppose, cloud is accessible through internet only. Nowadays business are moved to cloud. So here you can just modify your NAT configuration. Instead of using interface, here I used interface IP address for the translation. I can say no to this and Again, it is in mapping, so I cannot remove it. I can clear the NAT table, then I can remove it. I can say IP NAT inside match source from access list number 10 and translate it into the IP address from the pool. From the pool, let's say pool name is PM, and then overload. Overload. What it's saying? Dynamic mapping is in use, that's why you can't create entry. So do clear IP star clear IP NAT translation star, and then say no to,
So stop pinging from the PC.
So pinging is working.
and then here is my new NAT configuration where it is. Let me add IP NAT inside source list 10, translate it into the public IP address from the pool and use pool PM and use overload means port number. That's it. Now can PC access internet? No, because right now we don't have any pool with PM name. So in that pool now I can configure a range of public IP address IP NAT pool PM, and here starting IP address is 1.1. Let's say 50, and end IP address is 1.1.51, and net mask is 255.255.255.0, right? Again PC1 can access internet, and router will use same public IP address, first IP 1.50 NAT translation. Here you can see 50. Until and unless this IP address is not occupied with all port number, it will not use second IP in the pool 51 1.1.51. Even PC2, if PC2 is going to access internet, it will be using same port number, sorry, same IP address. You can see for 1.2 same IP address, but port number is different. Port number is different. Now if you want to integrate here, what, let's suppose DNS. So you have the DNS server, you can create DNS entry IP domain name, let's say pmnet.com, and what was the command to configure IP DNS host IP DNS server primary DNS server. Okay, DNS is enabled. IP host pmnet.com, and IP address I can say 8.8.8. So now if your user will browse this domain name, your DNS server will resolve into the IP address 8.8.8, and here you can define the IP DNS server IP address to your PCs. That's it. So DNS is also integrated, NAT is also configured, and on the firewalls you will have some more options, but on the router generally we have these three types of NATs. Let's revise it. Static NAT, 1-to-1 mapping, one private IP address will be translated into one public IP address. Dynamic NAT, many-to-many translation, and dynamic NAT and PAT are unidirectional, means only you can access internet, your employees can access internet can't access internal servers, internal user. Got it? So dynamic NAT many-to-many, and PAT one many-to-one, means many private IP address will be translated into one public IP address with the help of port number. And how it will assign the port number? Randomly. From which range? From the free range. One port number for source, one port number for destination. And if I am going to send Let me show you one more thing here. On the router, now I am going to remove one-to-one netting. Do so, run section IP NAT. Let me remove a static NAT, source static, this one. And NAT rules will be also checked in the same sequence like your ACL. If multiple rules are there, router will start checking from top, and it will be checking all the rules until match will not found. Right, now go to your DNS server and ping 8.8.8, ping 8.8.8.8. See, when I am pinging 8.8.8 IP NAT translation, so IP NAT translation. Here is my translation, clear IP NAT translation star. I have cleared it. From the PC1 and 2, I am going to stop communication. Let me clear the NAT table once again, and so IP NAT translation. Now you can see we don't have any translation entry. Now from the Google server, sorry, DNS server, I am going to ping 8.8.8. Ping is working. Their IP address, private IP is 1.10. Go to router 1 and check translation table. You can see inside global IP address means my public IP address, my private IP address, and outside local, outside global. Guys, ICMP is a layer 3 protocol, right? So in the actual traffic, there will be no any port number, right? Your traffic will be not having any port number. Your traffic will be at layer 3. The actual message is ICMP request message. It has used random port number. For inside local, it has used 3. For inside global, it has used 1024. If I am going to send telnet traffic, telnet 8.8.8.8 NAT translation. Again, you can see when I am sending telnet traffic, then destination port is well known, right? So you can see for outside local, port number is well known port number, which is 23. Well known port number. But for inside local and inside global, it has used again the random port number only, right? One was the source port number. Actually, your server is going to generate traffic with random source port number, that is this source is 1024 and destination is 23. So that will be source will be your local, inside local, and outside global will be well known port number. For layer 4, layer 5, layer 6 and layer 7 traffic. For layer 3, layer 2 traffic, it is going to use random port for all types of zones. For outside local, outside global, inside local, outside local. Clear? NAT is a technology used to make communication possible between private and public subnet. How? With the help of translation. Your edge router is going to translate private IP address into the public IP address when my traffic is going from inside to outside, right? And in a static NAT is for bidirectional, means either my server can generate traffic for internet, like if anyone will ping on the private IP address, that private IP address will translate into the one public IP address, or anyone is going to ping that public IP address, and that will be get translated into the private IP address, single private IP address. This way NAT work. For you, I can give you the one homework. For NAT, you can do one thing. You can just design this topology where two sites are there. Switch 1, and some end users are there. And I want you guys to configure this lab before next class, because tomorrow I am going to start a very, very important topic, which is VPN. Right now, see, understand one more thing here. NAT cannot make communication between two private subnet over public, right? Let's suppose these two are my private network. At both sides I have edge router. This is switch 2. Here my private subnet is 192.168.1.0/24. Here my private subnet is 192.168.2.0/24, and on both sides I have edge router. R1, R2, doesn't matter what IP address you are using on the LAN interface, that's not matter for me. And here is the internet. And you don't need to care about the public reachability, like if multiple ISPs are there, internet, because in production, in actual environment, you will have connectivity from ISP, right? Here you have one ISP, let's say ISP 1, and here you have another ISP, ISP 2. You will purchase connectivity from ISP. Like this. This can be Airtel, this can be Tata Communication, or simply I can say ISP 1 and ISP 2. And both ISPs are connected with internet, right? We know this. This will be your actual production. Doesn't matter what subnet is running over here, any subnet, what subnet is running over here, doesn't matter. You will get one public IP address over here, which is let's say 1.1.1, right? And ISP is using 1.1.2, and here your public IP 2.2.1, and ISP is using 2.2.2. So 1.1.1 and 2.2.2 will be reachable, and that is the responsibility of service provider. They will be using which protocol? BGP protocol, right? As soon as ISP is going to allocate this IP address, public IP address, it will advertise that into the BGP, and all the ISPs, everyone on the internet will have route for that. And on the internet now we have multiple public servers, 8.8.8.8. Here I want you guys to configure NAT. First of all, let me add one server here, which is my, let's suppose, FTP server. FTP server IP address 2.10. Task number 1. Here your private subnet is 10. Sorry, I have already mentioned. Let's suppose this is LAN 1 and this is LAN 2. And here is your task. Tomorrow I will check. Okay. Number 1. All internet users should be able to access FTP server with 2.2.2.10 public IP address, right? With this public IP address, all the internet users should be able to access FTP server with this public IP address. Means on router number 2 you will configure what? A static NAT. Yes, one static NAT. Task number 2. All users in LAN 1 and LAN 2 should be able to access internet with private IP address, or let me remove it. Private should be able to access internet means you will configure what on router 1 and router 2
NAT.
PAT. Use PAT only. You are not allowed to use PAT. And after this, I have one question. Let's suppose here I have configured the PAT. Here I have configured the static NAT, SNAT. SNAT is going to be source NAT. That's why I say static NAT. And you have configured PAT. Now my question to you is, can LAN 1 and LAN 2 communicate with each other? Can 192.168.1.1 ping to 192.168.2.1?
No.
No. NAT is communication between private and public, right? Or public to private. NAT cannot allow communication between two private over public. That is not possible. Got it?
Yes.
Yes.
This is your topology and you need to configure. And then one more topology. Here is, I have one router. This router is connected with internet. Here we have 8.8.8. Here I have public IP 1.1.1. This is my R1. This router is connected with one multi-layer switch, one MLS. MLS is multi-layer switch, right? Here you are using any private subnet 10.1.1.0/24, right? And on this MLS, I have multiple SVI for different departments. Let's say HR department, sales departments, right? Admin department, finance department. These are departments, right? For HR, I am using VLAN 10. For sales, I am using VLAN 20. So you need to create these all VLANs on MLS. VLAN 30. And for finance, we have VLAN 40. Right? Now, here you have SVI for, let's say for VLAN 10, you have 192.168.10.0/24. For 192.168.20.0/24 for VLAN 20, for VLAN 30, 192.168.30.0/24, and for finance for VLAN 40, you have 40.0/24, right? And your task is number 1, create all SVI on MLS, and okay, this is task number 1. Task 2, HR and sales should access internet with public IP 1.1.10, right? All the users means PAT, and admin and finance should access internet with public IP 1.1.20, right? Or I can add one more thing. Let's suppose one more department is there, which is engineering. So engineering department is for VLAN, let's suppose VLAN 50, and engineering department should have only HTTPS access on internet. Internet means limited access to the internet. To which department? Engineering department. Rest all the department will have full access of internet. Here engineering department. VLAN 50. 192.168.50.0/24. So these are your task, two task. Configure it before next class, and tomorrow I will show you how these two private subnet will talk with each other. Like as I told you, NAT is a technology used to make communication possible between private to public or public to private. Similarly, VPN is a technology which is used to make communication possible between multiple private network over public network. Means by default, two or more private subnets cannot communicate over public. So here you will create a virtual private network, that is your VPN, right? So we'll see that in next class. Before that, I want you guys to configure these two labs by yourself. Okay, now I'm done from my side. If anyone have any question, please
Sir, show me the second lab.
ask. Second lab is here.
Please share all the lab.
Definitely I will
Okay,
share.
thank you.
Right here you can have user in all the VLAN. Then you need to test that users are able to ping. If they are able to ping, you will check the NAT translation, that through which public IP address they are accessing. Why I am using multiple public IP address for multiple departments? So that later we can configure the QS, right? I can apply any policy. If all are using single IP address, it will be difficult to configure policy based on public IP addresses, right? So you will have these kinds of requirement in the production. Just 1 minute, guys. 1 minute, please. So now you guys are good enough to understand the problem in the network, and based on that learn the solution, right? Now if you have learned whatever we have covered till now, if you have learned those technologies properly, you have not remember anything, right? If you have understood and performed the lab, then trust me, learning all other technologies, whether it is SD-WAN, automation, ST-access, any SDN based solution, data center, is very easy for you, because you have foundation. Now you can understand, okay, this is the design of data center, this way traffic is going to flow, we know the packet flow, we know the behavior of routers. And but guys, you know, in the real time, when you will access google.com from your PC, like let's suppose you have typed www.google.com, you only know routing table checks, ACL checks, NAT checks, policies checks, but routers are going to perform more than 100 checks. more than 100 checks, right? So day by day, when you will be learning other technologies, you will be knowing many more. Like we have understood the label check, right? Label table. When router is going to look up RIB, when router is going to look up FIB, when router is going to look up LFIB, correct? When router is going to look up ACL table, NAT table. So like this, there are so many other checks as well. In QS, you will see one more checks. So more than 100 checks will be performed by router before forwarding traffic. CCNA, CCNP doesn't teach you everything, but CCNA, CCNP teach you, give you the foundation, right, to understand enterprise network. Now you know the foundation of enterprise. Just you need to polish. That's it, nothing else. Within 1 month, you can learn the SD-WAN. Within one month is more than sufficient. Even you can learn it by yourself. If you have the lab to practice, you can learn by yourself by watching videos if you are the dedicated. But anyone who ever have not performed all the previous lab properly, have not learned each and every protocols and features we have discussed before, then sir, I'm sorry to say, for you it will be difficult to understand even our next class, right? Because now I will be talking about the actual network only, actual enterprise network. In CCNA, CCNP, we are learning enterprise network only, like SD-WAN. SD-WAN is dedicated for these WAN edge devices, right? That is for management again, right? Like here we are managing WAN edge device manually, accessing one by one, configuring. So it is difficult. If I have 100 sites, 1000 sites, it will be difficult. So SD-WAN is easy management solution, right? Provide two things: management plane, centralized management plane, and centralized control plane. So you can understand, okay, this is the issue. I know this type of network, and here this is still this is the issue, and this solution is solving it, right? You can learn it very easily. Getting my point? What I am trying to say? I am just trying to say that this is foundation, and now I am expecting you all have good foundation, a strong foundation. If anyone have missed the class, have not performed the, no worry. Just start revising, and this time start learning everything one by one. If you want to revise, want to join live classes again, just message to our team. Because we want you to learn. Because when you will learn and then implement in your career, you will start getting benefit. When you will start getting benefit, that is our success. We want that. PM networking students should have always a strong foundation at least. Maybe they are lacking in the modern technologies, but they are good enough, capable to understand everything. For that, you need foundation. Even if you don't want to join live classes, take time. Revise all the topics multiple times, one topic one day. Then also within 2 months, you can complete all the revision. From 6th of this month, again new batch will start. I think many of you have not joined the switching classes till now, right? So those guys can join switching from the year. Whoever have completed are in mentorship can join the SD-WAN now. Now your next step is SD-WAN, but don't go for SD-WAN directly. You can start SD-WAN from tomorrow itself, but sir, it will be issue if you have any doubt in this foundation, right? So if you need time, just take your time, revise all the topic, make sure all the protocols are clear, all the concepts inside that protocols are clear to you. Like today we have covered the NAT. Now you can search some questions as well, the real-time scenarios from the NAT. You can try to understand that scenario, try to design the lab, configure it. There is no logic of learning if you are not performing the lab. Networking is practical. This is the reason why people love it. Everything is practical. You will love it, right? You will love to solve real-time scenarios, issues. And this is so important, most important part of your entire career. If you have good foundation, you can build a strong career, never dying career, because you are capable to learn, right? No problem if I don't know the SD-WAN. Problem is when you are not able to learn the technology, SD-WAN technology, not able to understand because you don't have foundation. You don't know the network, even you don't know what is enterprise, how the enterprise network looks like, what protocols we are configuring. If I will talk even this topology, so in this topology guys, even if I will talk about the complete configuration, so here you are going to configure multiple layer 2 protocols like TTP, you will configure VTP, you will configure STP or RSTP, you will configure ether channel, right? Layer 2 or layer 3 ether channel, you will configure port security, and we have already learned it, right? Then you will also configure many more things like port protected, right? MAC aging time, you will configure MAC aging time based on your needs, based on your business requirement. Which users are rarely accessing internet should have lower MAC aging time, right? So that switches should not keep their MAC address in their table for long. It's like that. People who are usually often access internet should have more MAC aging time, so that switch should not perform a non-unicast flooding again and again. See, remember our switching classes. Then for layer 3 between distribution and core, you will configure routing, right? You can use OSPF. Between your VANED devices to other side VANED devices, you will configure BGP protocol, right? You will configure NAT protocol, BGP. You will configure NAT. You will configure VPN in the single topology only. So I want you guys to implement these all protocol at the end in one topology. That is going to be your project. That okay, this is my project. Even you are the fresher, you can consider that as your experience that I have hands-on, right? Even we can give you the letter that you have performed hands-on experience on our lab, right? You can use that in your job to get job, but you have to show us that, see Praful, I have designed this enterprise network and I have configured, here is my configuration. You can verify from your team that everything is properly configured or not, communication is working or not, right? ACL is working properly or not. You can find the requirement of business, right? Based on that you can create ACLs. If you are capable to configure the enterprise network or any project, we are happy to share even experience letter from PM networking that can help you to get job. But I don't want to share it with anyone that hey, I was the student at PM networking, give me the offer. No, that is not possible, sir, right? So start performing. If anyone have not performed basic lab, for those who want to revise in the live classes again, contact to the team. For those who have not learned switching till now, again contact to the team that from 6th of November, please add me in the group so that I can learn the switching technology from there. I have not completed there. Whoever have learned, wait a
Sir,
minute, wait. Whoever have learned NANP, completed everything from the sketch to till here, and few more classes are there like as I told you, VPN, IPsec, DM VPN, and for MPLS we have already covered the VPN. Like you are learning two things: VPN over MPLS transport and VPN over internet transport. So till VPN, everything should be clear and crystal. When you are clear and crystal with everything till WAN technology, LAN and WAN, both, all the protocols, then only go for SD-WAN. Again, you can message to team that, hey team, I have completed my NANP, now please add me in the SD-WAN group. You can start your SD-WAN from there. Or if you want to learn firewall first, next generation firewall, you can let us again know that, hey, please add me in the FortiGate firewall batch. They will add you. But guys, you all have the notes, you all have the resources. Even we are available to help you every time if you will stuck somewhere technically, whether in performing lab or understanding any theory. Even students can help. You can put the query in WhatsApp group. So utilize it and master it, learn it. If you have not learned, and for those who have learned everything, understood, are able to perform the lab, oh, many congratulations. Now you need to learn the SDN networking, because the fact is, I don't want to say this to everyone, but this is fact, that networking is replaced by SDN, right? But you can't learn SDN directly. You have to learn, go through networking only. There are some unnecessary things also. I am working professional, I know what you need to learn. So whatever I explain here in the classes are really very critical skill and very useful skill. Without this, you can't learn any other technology. Okay, so hope you guys have understood and you will follow this. Now, what was your question, Ahmed?
Sir, in this running course, we are defining the switching, or we will start
What?
the switching section.
Here we
Actually,
have
when I,
covered the switching.
so sir,
No,
when I
sir.
joined this class,
So same I told you now, whoever had not completed the switching will be joined from another batch, right? You will be receiving the group. I think you are from the August batch, right? August combo batch,
Yes, sir.
Yes.
right? So your next module will start in that batch from 6th of November, right? But
Okay.
so many students are there from last mentorship batch. So now those guys
Okay.
will go for SDN, either SDN or firewall.
Sir, for CCNA, CCNP combo, no, we have only few classes, right?
Right.
How many classes are left, sir?
3 to 4 classes.
Sure.
3 to
Sure.
4 classes. I am going to take 3 to 4 classes. After that, you will have mock interview session, right? Arun will be also taking session. You will have resume building session, right? Where we will guide you for resume building. So you have to inform us
Sure.
that yes, I am done with the technical part. Now let's move further, right? You will be informed. Don't worry. In your WhatsApp group,
Sure.
everything will be shared.
Sure, sir.
And I want best answer as well in the interview. That is my feedback as well. I also ensure from other team members that, hey, please you ask the question, you tell me that I have delivered the training or not, they are able to answer to the questions or not. If you are not able to answer, that means I have not delivered. This is not 100% true that there is fault of trainer, but might be possible that I have not delivered what I was supposed to deliver. So I think I explained all the topics very well in easy and practical language. With labs, we have configured the lab as well for each and every topic, so you guys will be able to answer in the mock interview session. And later I will also watch your session, so then we'll see if anyone will be not able to answer it in the mock interview session. Then again we will suggest you, right, to join our another batch or to join our webinar kind of things. Like sometime we are launching private webinar as well, right? You guys are not aware about that till now, so we will allow you. And in that we have private videos, right? So if let's suppose someone is not able to answer from the ACL topic, right, so maybe team will share one video on the ACL topic with you only, right, that please watch this video once. Again they are going to ask you, right? So we will leave you completely when you are able to answer us properly to the topics which we have covered in the class. Got it, everyone? And start designing enterprise network as well, right? In your EVNG, or EVNG will be the best, right? Because in GNS3 it will be difficult to configure switch. So I will recommend all of you to create enterprise network in your EVNG, right? In the enterprise network, you know the topology, like this topology. Oh, I stopped sharing my screen. You need to design this kind of topology, right? Few things can be different, like if someone is working, right? So you can design your company network, right? But I want similar kind of network, company network configuration. See this kind of topology. See this kind of topology. This can be your first project, right? Where you can see multiple access switches are there, then two distribution, then one core, then one firewall connected with multiple ISP. No guys, before talking about VPN, we have one more thing in the NAT, like when you will have multiple ISP, then how you will configure NAT failover. So first tomorrow we will cover that. After that we'll see it. Here you can say PM. See this can be your lab, right? Where you can see in single lab I have two transport, internet and MPLS, right? It is just connecting two sites, but we have multiple transport. So here you will configure VPN over MPLS as well as over internet, right? This can be your one project. So now you guys need to configure this kind of network. This one is not required. This topology, I had created this video for beginners, like whoever are looking for basic project. Like this is for college students, right? Sometimes they need project in their college, so they can use it. See this network, this will be your best network, where again two sides are there. In the both side you can see the LAN, and you can have different design as well, right? You can have less switches, more switches, but two sides and both are connected through internet. This can be your one lab, right? This can be your one lab, and I had shown you one another where multiple ISP was there. That can be your one lab. So at least configure 5 enterprise network. How many? 5.
5.
Right? Take 2 days for one, means in 10 days 5 project. After that, do your research and also do the documentation. Documentation means what subnet you have used where, right? What protocol you have configured where. So those things. Hello? Yes, Arun? Calling you back, brother, in 5 minutes.